Okay, we're back. Harley, can you hear me? Harley. Oh, there he is. There's Harley. Okay, we're back.
Hey, okay.
We're on. I don't know what happened there, but I'm the organic mechanic with Kelp4less.com, and on the other side of the screen is the undisputed hydro weight champion of the world, Harley Smith. And here we go again. Boy, we appreciate all the views and all the questions, and we just want to keep throwing information out there and uh, see if we can help someone in their garden and their farm and whatnot. And we have an interesting question today, a viewer question, and I thought I'd bring this up with Harley because you could probably shed a lot of light on this topic. And it might be elementary for some, but it might be very interesting and intriguing for others on this topic as we go through. So, with that being said, Ken wants to know, Harley,
Oh,
can you explain how different strains are created? And can you explain how the expression of genetics is carried over in the new strains? So, that's a good question, a good topic, and I'm sure you can shed a lot of light on that for us. So this should be interesting.
okay. Yeah, that's a very good topic. I mean, hey, both of us know there is no substitute for genetics. We as growers are trying to help the plant reach its true genetic potential. And we're selecting, as breeders, we're selecting for specific characteristics or
Right.
qualities. But it's up to us to bring that up. But you can't, if you're limited by genetics, you're not going to surpass the genetic potential of the plant.
Hmm.
So that's really a question of selection. I've often been asked kind of a similar question of what's better, growing from seeds or growing from cuttings. I guess that's a good place to start when you're talking about breeding. When you're growing from seeds, that's seeds are the result of sexual reproduction, where you get the pollen and you pollinate, and then it
Hmm.
makes seeds. But no two plants growing from seed are exactly alike. They're all unique individuals. So you can have, if you're growing from seeds, you can have tall plants, maybe here and there, extra tall or extra short, or some maybe a little bit different colors or a little different aromas, maybe a little bit different, um, let's say, medicinal characteristics, qualities. Um, but they're all, so there's a lot of diversity. So if you're going to be doing breeding, you definitely want to have a lot of different varieties or different characteristics to choose from. Now, if you're growing from cuttings, every plant grown from a cutting is genetically identical to the mother plant. So if you were grew plants from cuttings with the same exact nutrients, the same environment, the same lighting, everything's exactly the same. Theoretically, you're going to have um, reproducible results. They go
Hmm.
from strand from grow to grow to grow. Now, I just lost you for a second there. I think you're
I
still there.
know. Sorry about this here.
It's okay
Let
though.
me
You can
back
still
in.
see me and hear me.
Yeah,
So
there we go.
the idea is to, when you grow from seeds, define the plants that have the characters, I call them superior characteristics that you're looking for as a grower. And then you take that 1 out of 100 or 1 out of 1,000 seedlings, whatever it is that has that. Oh, this one's special. This one's a little different. This one is better, in my opinion. Now, what's better? That has to do with the grower of what he's looking for. But and then once you have that one superior plant out of all those seedlings, then you can do cuttings to be able to reproduce those characteristics over and over again and bring it to market. Now, once you have a plant that's a new mother plant that with the special characteristics, you can use that in your breeding program and breed that, cross that, the pollen or the that mother, until you get a whole bunch of other seedlings that some of them will have that characteristic, and some may even have some other characteristics that are superior. And that becomes your new mother plant. You can even rename it if you want to as a variety. So it's a process of of selection for specific things that you're using, and then using that in crossbreeding to bring those and make improvements on that strain. Now, I will say this: one of the downsides of the cuttings is that sometimes there are genetic weaknesses. Maybe it is genetically susceptible to powdery mildew. It
Yeah.
doesn't have the same strong immune system, and which is controlled again by the genetics to a degree. And you don't know it. It's hidden until the conditions are just right. And then not just one plant, but all of your plants are going to get that disease.
That's
So,
right. Conditions is perfect. We don't want
so
that.
yeah, so that so it's really important in a breeding program to be able to do both if you're a breeder, because some of those plants from those seedlings are going to be have a genetically strong against that particular powdery mildew. They won't get it even if the conditions are right. And I've seen it. I've seen it where I've had seedlings and then something went wrong in the environment, or got really humid, or got too cold. Something was wrong, and some of those plants survive. Just maybe only 20%. And all the rest die. Well, those 20% that survive, they have the genes that are good for the resistance to the problem. They're stronger against disease, and genetically, you can use
Okay.
that, breed it with something else that has a characteristic that you're looking for, maybe like color or flavor or aroma. And if you can get the right combination, now you have a superior strain, and that can be very significant. Did you know that lettuce used to be a medicinal herb
Mm.
back in the past? It was a medicinal herb. But over time, as as gardeners, we bred out all of the bitter because we wanted sweeter, maybe bigger, crunchier leaves, what we thought was better. And we bred out all the medicinal characteristics. So today, most lettuces, they have very low nutritional benefit, low minerals, and they do have vitamins and stuff. They are still good, but they're mainly just something to put salad dressing on. So we have to be careful. We as breeders, if we're selecting for one thing and for to increase the, say, medicinal compound, we might be breeding something else out over time.
That's
So
right. That's right.
we don't
And this
always know
product,
what's best.
yeah, and during this process, you can get tied up into this for years and years and years and years, getting the expression that you want. And I'm sure for some people it never ends. They're always pushing it, always testing it, always trying to go to the next level. And I mean you could do this for decades, centuries, which we have seen in some of the other plants like you described. Exactly the same thing.
Hmm. So we might be able to have new hybrids today from years of crossbreeding and selection that produce great yields. Oh wow,
Mhm.
look, we've doubled our yields over the last 20 years. But what about the nutrition? Have maybe the nutritional value has actually gone down. I think that is the trend. When all you're concentrating on is yield and neglecting some of the other things,
Yeah,
it's
yeah.
almost inevitable at some point. I think that the food that we eat today is lower nutritional value than what our grandparents ate.
Oh, it's proven. It's proven. Proven time and time again, test after test. It's just a downward slope. It truly is, as far as from a commercial aspect.
Yeah,
Um, a lot of conscious growers and farmers and things like that that do concentrate on nutrition and food density. It
yeah,
can be found, but not
Hmm.
on a massive scale like what we're used to. That massive scale production, yeah, minerals are going like this, while yields are going like this and kind of toppled off. So the yields have kind of topped off, but the nutrition is still going down.
Yeah.
We got to reverse that trend. So maybe what we're talking about can help that.
Well, yeah. Yeah, we're growing food that has more calories but less nutrition. And when we're trading off the calories for nutrition, what happens to our bodies?
We get
You know,
sick.
we we can get sick. We can get,
Yeah.
oh, we're putting on lots of weight, but that doesn't mean we're healthier. We're not starving, but we get more diseases in the end, more sicknesses. So, but here's the good news. Okay, that's the other side. Question number two is the expression of the genes. And we have that because you can have the same exact clones. They're genetically identical. You grow them in a different environment or with a different fertilizer ratio or biostimulants or microbes, they are going to look differently. It's called genotype is the genes, phenotype is the expression of those genes. I've done it. I've grown plants, I've grown clones that I do really well with. I like them. My cousin says, "Oh, I'd like to grow that too." I said, "Okay, here, I'll give you some cuttings." And they grow it in a different environment. I walk into his grow room or into his garden, I don't even recognize the plants. They're that different because of the way that we're growing. So, yeah, we can take plants that maybe we can improve the plant's natural resistance to pests and disease just with the biostimulants and the microbes that we're using, because then it literally stimulates and activates different genes in the plants. So, yeah, but still, even doing that, we can still grow more resistant, healthier, nutrient dense plants, hydrix plants, just because of what we're feeding them and the environment that we're giving them. But we still are going to be limited by the genes. So, really, it's really a combination: genetics and environmental stimuli. Put the two together, and we can reach new plateaus in nutrition, disease resistance. We can grow better food, more food, and also healthier food for us, and protect the environment at the same time. So the problem is, as you've seen it out in commercial agriculture, is that we've almost bred plants to be addicted to nitrogen, or
Oh
being addicted that
yeah.
they're so uh, non-resistant to diseases and pests that we have to spray more and more fungicides, more and more pesticides, just to be able to save the crop. Where if we give them the right nutrition and the right balance, then you won't have to use as much pesticides and fungicides and herbicides in the area. They'll have stronger plants too, and that's kind of I think that's my goal. Yeah, we need to do selection, but need to work on genetics. I mean, that is the new frontier. We have the technology. Let's use it.
Mm-hmm.
Let's use it in a good way. Let's use it in a way that the plants will make more vitamin A. Let's don't
Mm-hmm.
use it in a way as, oh, we can spray more herbicides on them. You know what I mean?
Right.
So we have the
Right.
tools to make the world a better place.
So I worked with a tomato grower one time that he would start from seed and he would start his stock, let's say, just a common greenhouse variety. Let's say like Blitz, a tomato variety. He would start that stock. Then he would start from seed a cherry tomato seed. And what he would do, he would graft the Blitz top with the cherry tomato root base because genetically that cherry tomato root base was so much more massive than his traditional greenhouse strain. And it was a lot of extra work, grafting those together and doing this on a large scale. But I'll tell you what, the difference was phenomenal. The difference in yield, the difference in uh, uh, water retention, nutrient absorption, everything. So I know that's not creating a variety, but he's taken two genetics from two plants and fusing them into one for an outcome. Is have you ever been in that aspect of gardening or growing?
Oh yeah, especially when working with the hydroponics in space. For example, dwarfism for
Mm,
for fruit trees. You know, dwarf
yeah,
fruit or super dwarfs. You
yeah.
know, that's based on the rootstock. That's where the dwarfism is. So if you can have a scion or a regular tree and graft it onto a dwarf rootstock, you can grow smaller plants. Now, why would you want to do that? Well, shoot, if I wanted to grow some small, cherry plants instead of cherry trees indoors, just so I can have a little variety. I can't grow a 30-foot tree. So, but I could
Right.
grow, you know, 10 branches or 10 little plants in pots if I wanted to. I mean, what do you want, right? I mean, do you really want to
Mm.
do that? Sometimes it's just not really feasible, but as a hobbyist, you might want to do. I knew one guy, I called him, we used to call him Howard Hughes. He was a rich guy, a very super wealthy guy that made all kinds, he was old man, but he made all kinds of money in the stock market. He was
Oh,
just,
you've told me a lot about this guy. Yeah, this is
yeah,
great. I love these stories from
this
this
guy
guy.
was just,
Yeah.
yeah, I loved him. He was really bright. He was really, but very eccentric. Okay, let's put it that way. And he had a, so he wanted to grow lemon trees hydroponically indoors. Why? Because he'd come in one day and said, "Oh, I I I harvested 14 lemons and I made a lemon pie." And he was just grinning ear to ear. And I think, wow, growing indoors under lights and all the systems that he had, and he was automating everything. He had an automatic doser for each plant. I go, oh my goodness, this is crazy. The most expensive lemon pie on the planet Earth, but it made him happy. So, I
How
mean,
many times
things
did
that
you get
we
to visit? How many times did you get to visit that place?
oh, I didn't actually visit him, but was coming into talking to me all the time. And he
Okay.
did offer me a job one time. He says, "Look, let's get into a tissue culture lab, and we can do some genetic engineering and things." He says, "I'll buy the lab. Set you up with all the equipment, and you run it." And I thought, no, because I know this guy's so eccentric. He'll throw a bunch of money at it, but we'll never make a dime in the end. So, but no, I really did. Again, the what is it that you want as a grower?
Yeah.
Sue
A lot of
kept telling me,
possibilities.
yeah, my
A
wife
lot of possibilities.
over and over again wanted me to grow sweet corn in my basement under lights. And again, I was like shaking my head. I mean, Sue, that would be the most expensive sweet corn that you can imagine with all that light, all those watts. She goes, yeah, but in at Christmas dinner, wouldn't you like to have fresh, right off the corn on the cob, right from the plant? I said, that would be really expensive corn. She goes, but it would be the only corn that you could get at that time. So so I say, so I'm shaking my head. Some of the things that we can do maybe are not feasible, but other things that we can do are economically feasible, as well as just making us happy and improving quality of life. So that's our decision. That's what we get to choose as growers. What do we want to do?
Yeah. Have fun, feel good, and learn things in the process. Yeah, those are some good examples. The possibilities. I mean, truly, it's just how imaginative can you be? How far can take things, in the direction you want to go? It's kind of fun. It's challenging too. It's challenging and learning all the time. And anyway, I hope this topic kind of help people imagine a little bit more in what they can do in their garden. And again, we need to have fun and grow something worth consuming. And that's the whole goal.
Hmm.
Something good for us to consume.
Yeah, and no matter what your genetics are, I feel like but the right environment and the right nutrients and biostimulants are going to be beneficial no matter what you're really growing,
That's right.
because
Yeah.
we're working with nature in an intelligent way to help
Excuse me.
help express the genes that are already there. And you'd be surprised. You think here's one with breeders too and research. They think they know the genetic potential. Under in this environment, you can't get any better, right? This is it. We found the plateau. But it's not true, because we started doing something with a bloom stimulant, and we can see 10-20% increase in yield and better quality. And you think we already were there. So we really need to work. We need to know really understand the needs of the plant and find better ways to meet those needs, as well as doing the breeding.
Well, hopefully when we continue this podcast, we'll keep getting to those levels. We'll keep pushing it further. We'll keep, getting bigger, better, higher quality. That's one thing we're about. It never stops. We can keep pushing it forward
We can.
and have a
All
good
right.
time and have a fun time doing it.
Oh, it's fun. It's challenging, and sometimes you get a little discouraged because nature finds a way, and I don't understand it. I'm doing everything right, but not getting a good result. But there's much more trial and success over time working with nature
That is a
than there
good
is trial and error.
that is a good statement, and it's probably a good time for us to sign off. We're about
I
at
think so.
our time limit, and I have an idea. Let's do this again next week. How about it?
Hey, yeah, I'll be here. I'll
Okay.
see you
Don't
next
don't
week.
go anywhere on me. Yeah, don't go
I
anywhere,
won't.
Harley. We'll see
I
you next
won't.
week.
Great talking to you again. One of my favorite time of the week. Let's put it that way. See you next week.
Of course. See
Bye.
you.